Welcome to Copper's Reappearing Act. The Copper Reappearing Act is another one of the 3 labs we do that are preludes to the Copper Cycle Lab. Copper's Reappearing Act is essentially the exact same lab you just did with the iron-copper switcheroo, except for 2 super important factors. 1, you're not using iron, you're using zinc. 2, in this reaction, the copper in the copper 2 sulfate pentahydrate is going to be the limiting reactant, not the neutral pure metal. Finally, because we want every last atom of copper harvested from the solution that you are going to make, we want every last atom of copper precipitated and captured in the filter paper you're going to use. We'll use a little bit of excess zinc. The excess zinc then we've got to get rid of, and once all the copper is reacted and precipitated. To get rid of the zinc, we're going to use 3 molar hydrochloric acid. Let me show you how to do it. The dissolving of the copper 2 sulfate pentahydrate is the exact same step as from the iron-copper switcheroo lab, so do the same thing. Make sure you've got a nice single blue flame, and as soon as you see all of the copper is dissolved, you can turn your flame off and move on to adding your zinc. The amount of zinc that you're going to add is this value down here. It's 1.25 or 25% more than you calculated. And that's because we're using intentionally excess zinc to make sure that every last ion of copper is precipitated from solution or is reduced so that it is pure metallic copper. Make sure that this value here is somewhere in the 0.6 or 0.7 grams. Look at your worksheet now. If you don't have 0.6 or 0.7 something grams, hopefully to at least the thousandths place, because that's how far our scales in the lab go, come and talk to your teacher now. We'll figure it out. The mass of zinc you should measure out should look something like this. If you have a big pile in your weigh boat, or just a few crumbs, chances are your calculations are wrong, so come and talk to your teacher. Step 6 of your lab says delicately stir in the zinc. So I'm going to let a little bit of zinc in, drop a little bit, shake a little bit of zinc in while I'm stirring. I'm going to do that until all of my zinc is in there, and then hopefully the blue color will all go away. The only reason it's blue is because of those copper ions in solution. The wavelengths of light that the copper ions give off mix into this beautiful blue color. All copper salts are blue. So make sure that for the rest of the year, when you see us ask you to use the copper salts, then you know to grab the blue ones. After about 2 minutes of stirring like this, my blue color is gone because all of those copper ions have gained electrons from the zinc atoms. That gaining of electrons is called reduction. So the copper ions were reduced. That means they're an oxidizing agent because they stole electrons from the zinc atoms. The zinc atoms, in turn, were oxidized. That makes them a reducing agent. I know it's confusing. Just remember that there's copper in the bottom there and probably a bunch of extra zinc we need to get rid of. We used excess zinc on purpose to make sure that all of the copper would come out of solution so we could measure exactly what we've calculated to be in the copper 2 sulfate. That copper 2 sulfate pentahydrate has been converted to pure copper, and we should have zinc sulfate in here, aqueous. All right, let's get rid of the excess zinc now. Go over to the supply beaker, and which is in the middle of the room. Get your 3 molar hydrochloric acid. That means this hydrochloric acid has a concentration of 3 times Avogadro's number for every liter of solution. and add it about 1 milliliter at a time. This doesn't have to be perfectly precise. Just add a little bit and stir. Keep doing that until you don't see any fizzing at the bottom. I don't see any now, so I'm going to add a little bit more hydrochloric. You'll notice a couple things. Now that I've added the 5 milliliters of hydrochloric acid, 5 milliliters of 3 molar hydrochloric acid, you'll notice that the solution is cleared because the suspended atoms of neutral zinc ionized. Now I've made zinc chloride. The cool thing is the copper isn't going to ionize as easily as the zinc. So we don't have to worry about dissolving the copper. The zinc, however, you can see it. This is the second thing. You can see the zinc right there. So you kind of want to poke at the zinc and stir until you no longer see effervescence. Those hydrogen bubbles coming off of the solution are due to the oxidation of the remaining pure zinc by the hydrochloric acid. You're making zinc chloride and hydrogen gas. All right, I'm going to keep doing that until all of my zinc is gone and the bubbles stop. Give this step of letting your zinc dissolve up to 10 minutes. Be really, really patient. You're going to need about 10 minutes for this, and then you're going to need about 3 or 4 minutes to rinse the solids, and then you're going to need maybe another 4 or 5 minutes to filter the copper. So pace yourself. Once you've been poking and prodding at that darker colored zinc, which is sitting on the bottom of the beaker, and once you're happy that your solution is cleared and that the bubbles have gone away, then I want you to decant into one of these beakers. The first time you decant, make sure that it doesn't go down the sink because you've got zinc ions in that solution and there's toxicity to the zinc, and you don't want to put that in the oceans. I'm holding the glass stirring rod on the top of the beaker and pouring into the waste bin in the middle of the lab. Don't pour any of the solids out, just pour the solution. All right, there we go. Now, if you see any black specks at the bottom of your beaker, there we go, then that's the zinc. And you might want to add some more hydrochloric acid to get rid of it. Once you're all happy that your zinc is gone, then you need to get this copper into a filter. The biggest mistake in these labs having to do with filtration is forgetting to mass your filter paper. Make sure you fold it and then write your name on the outside in pencil, and then get the mass before you get this thing wet. There's no going back once this filter paper is wet to find its original mass. I'll remind you that when we come around and hand you the filter paper. All right, everything else from this point on is just like the iron copper switcheroo lab, except for one thing. You may want to make sure that you don't acidify your filter paper, you may want to add deionized water to your copper sample to wash it, and then decant that again. All right, the low pH of the hydrochloric acid could erode or ionize the filter paper, put holes in the filter paper. Or it could also cook the filter paper and oxidize it in the drying oven. All right, so I recommend highly washing your copper, decanting what you washed. Don't pour any of your solids down the sink. And then follow the rest of the steps for the iron copper switcheroo lab. Get this into your filter paper, fold the filter paper over the top, put it in the drying oven, and we'll weigh it out the very next day. Thank you. Good luck.